Recording in progress. Good evening, y'all. This is Platoon, Platoon, evenings, weekends, Module 5, Django, Week 13, Day 2. I'm Jordan. We're talking about, uh, well, this isn't a great topic name. Basically, what we're doing today is custom URL endpoints and testing URL endpoints in Django. We're going to be expanding the endpoints and we're going to be implementing tests in a way that is both expendable and organized and clean, and I like it. For today, you'll be using starter code, which is yesterday's lesson. If you want to do that, keep it nice and clean. Make sure you're on the end of day 5 branch. You can close that down and then get checkout to pull that one up. I already did that. By the end of this lesson, we will have a better understanding of flexible endpoints and how to implement tests to both URLs and views. We're not going to be digging too deep into implementing tests, or rather, okay, we will be implementing. We're not going to be writing them. We're basically copy pasting a lot of what you've already done, I believe, yesterday, and just reorganizing it. But you're going to be implementing in terms of a wider scope of Django, being able to run all your tests at one time. Not real crazy, nothing real difficult in the concepts today, just piling on to what you know. But flexible endpoints are super cool. You could probably build this yourself if you had the gumption to, but we're going to show you a way to do it, a conventional manner in which Django has some tools built in for you to kind of get this going. So let's talk about it. So to expand on our current endpoints, create the ability to grab a specific instance from our database. Right now, I'm pretty sure you can feed a Pokemon and a string, but we also want to be able to accept an integer. So we need to build an endpoint that accepts one or the other and then knows what to do with it. Let's read it off. Now, in order to use, or for a user to request a specific Pokemon instance, we need to give our user a way to give that specific information. To give us that specific information, either the body of the HTTP request, the URL itself. Django's got a bunch of built-in parameters, but for the purpose of this course, we're going to do string, int, and custom. So in this case, we're telling Django that after Pokemon, we will receive an integer and it will be ended by a slash. Here, meaning if you were to give this URL and end it with a 1, a 22, or a 176, that would be good. But if you were to give it a name, that wouldn't work. This URL, similar, except it only accepts strings. So these won't work, these will. But want a flexible endpoint, we're going to work on how to do that. Because I don't know, you could code around this. You could make the URL, version 1 Pokemon /ID/ and then it knows to look for an ID or name /. You can do it that way. That's fine. This is how you would make it a little bit more flexible. And if you're building the back end and the front end, who cares? Do it the way you want to. If you're building a back end that other people will be using, not just yourself, and that makes sense, flexible parameters are kind of nice. But what if I need you got to be flexible? Django doesn't have that kind of built in. We've got some tools that we are going to leverage, but that's not just a thing that works. You could establish both paths, and Django will default to whichever one works, meaning if I built both of these URLs, Django would look at this one and say, well, that's not an integer. Oh, it must be a string. That can have issues. What if they gave us Blastoise 1, right? That would break that. Django would still mess up. That's not a strong, solid solution. Instead, we're going to create a kind of custom type for our parameter that's going to take both a string or an integer and know what to do with it. We're going to accomplish that by putting this file in our Django application. So within Pokemon app, we're going to create a new file called converters.py. It's where we'll put our converters. We will have one converter. Let me copy paste and let's talk about it. So we got a class, integer or string. This regular expression is a regular expression that matches any sequence of digits or alphabetical numbers. It is used by Django to match URL patterns against the incoming URL. So basically, this is exploring. This is specifying what is allowed. The toPython method is called by Django when it matches URL pattern that uses this converter. It takes the match string as input and returns the converted value. So this knows to go look for this variable. The toURL method is called by Django when it generates URLs that use this converter. It takes the converted value as input and returns a string that can be used in the URL. Yeah. Sound good? How are we going to use this? Well, we've slapped that in there. Now we can kind of import this into our URLs. Our URLs should be able to leverage these functions, this class we built. So in Pokemon app URLs.py, am I in the right spot? Whoa, where's my URLs.py? Hang on, y'all. That's not supposed to be missing. Am I in the right spot?
What branch are you on?
What's that?
What branch are you?
Oh, I'm on the wrong one. Like I told y'all, you gotta swap over. My bad. Ah, there we go. Ooh, back up. Sorry about that. I literally said that's what we had to do, and I didn't do it. Jeez. All right. There's our URLs.py. We can copy paste all this, but let's see. All we had before was Django URLs, views all Pokemon, and then a pattern for all Pokemon, and a few other things. Um, we're going to be using register converter from Django. Our explicit imports are all Pokemon, selected Pokemon. We haven't built this yet. That's okay. That's coming. And we need to import our converters that we built. Great. To use this custom converter, and ooh, did I not copy everything? I didn't. Ah, um, to use this custom converter in a URL pattern, you need to register it with Django using the register converter function. So if you're going to be doing this, you need to utilize register converter function from Django URLs, int or string converter. It will be referenced as int or string. So this is being brought in from that converters file we did create. We're referring to it as this, and we can set that as a new custom, I guess, parameter type. So instead of int or string, we have int underscore or underscore string. This is our custom type here. So not touching this. This was here before, but we are going to be utilizing it for the view we'll be building called selected Pokemon. So when our URL receives an int or string ID, we will be leveraging that against this selected Pokemon as view called selected Pokemon. So instead of getting all of them, we're going to get one specific one, either by their name or by their ID. Do you all follow that? Egg salad. We have a URL pattern established and created a type for a URL parameter, but how does that connect to our views? In Pokemon app views, let's create that selected Pokemon class that I talked about. View that will take in a GET request and the ID of the Pokemon the user is looking for, and then returns an individual Pokemon instance. Let's copy that, and then we'll talk about it. So within our views of the Pokemon app, throw it here at the bottom. Ignore all the stuff you've done before. We're not working on that view anymore. So select a Pokemon. It is a GET request. Notice ID is now a parameter and its value is being pulled straight from our URL. Right. The GET is going to have an ID that is passed to it. The request and the ID. The parameter will come in as an ID. We're calling it ID here. Let's initialize Pokemon as none and give it a corresponding query to set depending on the ID's type. Pokemon none. Great. Nice to have that variable built. If the ID is an integer, if that ID is an integer, notice what this converter is really doing is ensuring that we don't just get a string that we then have to interpret, right? It runs through this converter first. Remember, int or string ID. That's cool. What actually comes through the URL, what is, what that parameter is in converters.py is either going to be an integer or a string, right? In our views, we don't have to go and verify that it is a string, verify it as an integer. We've already done that conversion. We already have decided in converters.py it's going to be one or the other. This could be breaking for you if it came in and was always interpreted as a string or something. So converters.py is handling that no, you are definitely an integer, or no, you are definitely a string. That's why we can run logic on that now. If it is an integer, the Pokemon will be mapped to one we fetched by the ID. So we're going to go get that instance, look it up by the ID, select one from Pokemon where ID equal to ID is what that's doing. If the ID is a string, Pokemon objects get where name is equal to ID dot title invoked. Does anyone know what that does? I didn't, had to look it up. All that is, notice we're looking at it by the ID. Here we're looking at it by the name. ID in this instance would be a string. Dot title just does it capitalizes the first one, right? So if it was Pikachu, it's going to make sure that it actually is a Pikachu. That's a silly little fun little method there for strings. That's all that does. But in our database, we expect Pokemon to have a capital first letter. That's their titles, right? Since Pokemon is a single instance, it needs to be wrapped by bracket to make it iterable for the serialized function to turn it into a binary string. A lot of conversion going on here. It's a little confusing. I don't love it, but this is the dance for turning something from an instance into JSON in Django. We are going to set a variable called Django Pokemon, serialize into JSON that Pokemon. It needs to be wrapped because it needs it. Basically, it needs a list. Serializer is expecting a list. So when we establish Pokemon as an instance, we're going to wrap it in a bracket. That's what serialize needs. Serialized Pokemon is going to load it into JSON using that serialized variable there. And we're taking the first instance. We don't want it in a list. Basically, it's a list of one. It is, it's going to look like this. Pokemon instance. We don't want it in a bracket form. If you do a 0, then it just gets the first one, right? First in the list. You could probably do like a dot first if this was JavaScript. We're just grabbing the first one in a list. Python doesn't turn it into a string. Doesn't work that way. And then for the rest of this, we're going to splitting it up. Moves is going to be from that JSON. We're going to, sorry, JSON loads the serialized JSON. We're pulling out the fields of moves for the Pokemon, right? The new serialized Pokemon is going to have moves. This is a lot of song and dance to get exactly specifically what we want here. Sorry. Anyone want to dig deep into that, or would you like to move on? We're going to be returning a serialized Pokemon. Once you've done all that, users can now grab a single Pokemon instance by their Pokemon's name or Pokemon's ID. Yay, that's what we were trying to do in the first place. Now let's create a URL path and view for grabbing a single Pokemon move by name. As you may know, we've got the main project, we've got a Pokemon app, but we've also got a move app, an app that is for the moves alone. In there, we're going to add this. All we're really slapping in there extra is the selected move view and adding this other URL here. Nothing crazy there. We're not doing any kind of conversions. It just is going to know that that is a move. And it's expecting a string. So not really using anything new there. Now we can create the selected move class and take in the name parameter. So also within move app views.py, we're going to create a new one. Selected move. This is not new stuff. This is not new Django or new Python. We are just looking up a move once given a name. Sound good? To test this, and what it seems like a lot of people had issues with yesterday was the testing in Django. My heart does go out to you. It can be kind of rough to write tests for a framework when things are not always exactly what they seem, and you didn't build them yourself, and you're not quite sure of what it's supposed to look like. Here is a good way to organize your tests. And this is how we're going to actually test the endpoints. Some of these tests are from yesterday. Some of them are new. We are bringing in what was old and adding it here. But notice we've got tests.py within the Move app, and we've got tests.py within the Pokemon app. We're going to do a whole new thing here at the top level called tests. VS Code makes it this nice little red thing with a little a beaker. Is it a beaker? Is it a graduated cylinder? No. What is that? Test tube. Within, we're to create 3 files in total. One is testmodels.py. We're going to move all our pre-existing tests into this file. Once you've done that, you can delete the tests.py file in each app. Basically, it should look like this. We're going to be yanking everything out of there as to not cause any issues within test. We're going to create test models.py, slap all that in there. Now that we've done that, we can delete test.py, which should be all spoken for now, as well as the one here. Cool. We won't dig into the tests right this second, but we can break those down here in a second. Additionally, we're going to do a test views.py. Notice everything in this test folder is just going to be test. something dot py. Set our views tests in there. Last but not least, we've also got a test URLs dot py, which we're going to throw all these URL tests in there. Sweet. Now we can run the test suite. Ideally, we can run the test suite if this is all hooked up just fine and dandy by running Python manage.py test tests. This ought to work. Tests is the name of the file. Test is a Python manage.py command. Oh, goodness. Do I not? Let me pause real quick. I didn't run into this earlier. Resuming the recording. I had a little setup I need to do on mine. So we should be able to test this and see if there's any errors. If there are, we can chase those on down. Turns out there are. We ran 7 tests. There are 2 errors. Who wants to volunteer and fix this in front of everybody and look silly? Philip.
Um,
Actually, I feel like I call you on.
I'm not.
I'm calling you all the time, don't I? I don't know why. Yeah, just keep going. Keep going.
All right. I see something about the violates not null constraint. Um,
Yeah.
row contains Pikachu.
Let's go chase
So
that down, huh?
maybe it's something in the models.
Well, you would, yeah, I mean, it's something to do with models, but this is saying an instance in our database looks like it's borked. Where is this being created from? What is this Pikachu with this description? Where's that coming from?
Is that in our test files?
Let's look around. Test models. Uh, Test views. Oh, hey, there we go. So it looks like that's where it's being created from. Do you see any issues with it? With this error?
Is it not being passed in a value for captured or
Sure looks like it. How can we fix this? Is our test messed up?
I don't remember if captured had a default or not, but if we
Hmm.
Boolean field, so could we just put captured equals false?
Yeah, where would you want that?
Um, back where we just were, I think that was the test views, maybe test.
Okay.
Yeah.
Cool beans.
Do we have to migrate when we do that, or no? No, it's because it's Python, right?
That's I should pick that up, shouldn't it? Oh, that was just the setup. So we're still failing 2 tests. But notice, and it's a good thought thinking about the migrate. I might have done that ahead of time. What's this saying?
Um, it's trying to insert another row, and that we're failing.
We just need to throw it on the end here. Both of these Pokemon created in this setup need that. This is a good time to ask the question: Should it default in the model, or should we just give it the test it needs? That's up to you. It's your application, but ideally that does fix our issues. We have a clean bill of health from our tests. Big thing that I like to get across is there's a lot of traceback here. But a traceback is just telling you what file called what file called what file called what file until you run into basically what the issue was. And it does tell us right there. In fact, this bit tells us really, truly everything we need to know. But that's not like part of the lecture or anything. Just want to show you to read tracebacks, and they are built in there, and Django does decent-ish idea or decent-ish job of showing you what went wrong. Does anyone have questions specifically about what we've done here today? Cool.